Hey everyone, today I want to talk about four-term factoring, as in a four-term polynomial, something that has four pieces to it. So a four-term expression, remember we're still dealing with expressions, there are no equal signs yet. There will be. We'll get there. We've got four parts or four pieces. Take a look at example 1. You can see here we've got the four pieces. These are called terms. 3p to the third power, that's one term. 9p squared, that's one term. 5p is one term, and 15 is our last term. 15 is the constant term, meaning it's the number by itself, with 3, 9, and 5 as our coefficients. This is a third degree polynomial. The highest degree is 3, meaning the highest exponent. These are not quadratics. A quadratic only has a second power as its highest power. We can still factor these things though. In fact, with the area model, it's actually really easy. Way easier than you would do normally. So let's see how this works. Here's our trusty squares. What we want to do is we want to fill in these squares in order. So the third power, second power, that's kind of the first power. It's just the value with p, and then the constant. So let's do that. 3p to the third, 9p squared, 5p, and 15. Notice how nothing's negative here. We're going to make it easy first time around. So what do we do with the area model? Well, in previous videos, we just found the greatest common factors, and we factored those things out. So let's take this first column, 3p to the third and 5p. What can we divide out? Because remember, factoring is division. What can we divide out that both things have? Well, I can't do anything with the 3 and the 5. They're not divisible by each other. But they both have at least one p, which means that on the top of this box, I'm going to put p. Let's go to the second column. What do both of those things have in common? 15 doesn't have a p at all, so we can't take a p out. But I can take out something that has commonality with 9 and 15. They're both divisible by 3, which means I can factor out a 3. So the 3 comes out. And just like the area model, just like that, we've got our first set of factors. The first set of factors are p plus 3. Now let's go to the sides. 3p to the third and 9p squared. We got to be really careful with these types of things because there are multiple things we can factor out, multiple commonalities. Let's start with the variable because that's usually easier. That's 3p's, meaning there are to the third power. So there are 3p's in this term. There's 2 here, which means we want to take the greatest common factor out. We can take out p squared on both of those things because that's what both things share. So p squared is going to come out. Now remember, there's coefficients too. We want to take the greatest common factor out of both things, numbers and variables. So we can divide a 3 evenly out of both of those things, which means 3p squared is the term that comes out or factors out of both of these values. Let's do the final one and we can move on. We can factor out a 5 from both of those terms. And here we are with our answer. The factors of this third degree four-term polynomial are p plus 3 and 3p squared plus 5. And that's our answer. The area model makes it actually really, really easy. It's like too easy almost. So let's see if you can do a few on your own. Take a look at example 2. I'll give you the same amount of time it takes me to erase this thing to see if you can solve it. Let's see if I have a square. I do. And I have a third example. Let's make a deal. Try number 2. I'll erase this, and then we'll do 3 together. This is not wanting to erase. That stinks. I really need to clean this board because it's dirty. It's gross. Okay. Are you ready? I wasn't really counting, but I don't think that was even a minute. Let's see how good you are. 16v to the third power minus 56v squared, 2v, and negative 7. I like columns first. The biggest number, the biggest thing I can take out of this is a 2 and a v. So 2v comes up top. Negative 56v squared and negative 7. Well, remember, when either of these two numbers starts with a negative, I've got to take a negative out. Just the rule of thumb. So they both can be divisible by negative 7. Our first factor pair is going to be 2v minus 7. Let's go to the sides. Here, well, 16 doesn't divide into 56 evenly, but I can definitely take an 8 out. So the 8's going to be the number that comes out. And they both share at least 2 v's, meaning v squared. So 8v squared is going to come out of that. And then 2v minus 7. That's interesting. There isn't anything I can take out that's even. But we have to take something out. Whenever this is the case, 1 is the number that's going to come out. And there's our answer. This was probably a little bit trickier than you had thought. You're welcome. Our answer is 2v minus 7 and 8v squared plus 1. Final answer. Let's try number 3 together. 3r to the third, 3r squared, 8r, and 8. Commonality here is just r, so I'm factoring out an r. Nothing here, but I have to put a 1. Our first factor set is r plus 1. Here, I can take a 3 out of both, meaning factor, and I can take r squared out of both. So 3r squared comes out. 8r and 8, well, they both share an 8, so that makes it a little simpler. And we have our answer. The factors of this third degree 4-term polynomial is r plus 1 and 3r squared plus 8. Done deal. Okay, let's wrap things up. Things to remember on this video. Number 1, a 4-term expression is never quadratic, because a 4-term expression means that it has to have 3 terms at least that have variables in it. Well, if I have 3 terms that have variables in it, then a square is not going to be enough to have more variables in the other terms. So a 4-term expression, when we talk about factoring, it's likely going to have a pretty high value in terms of the exponent, or it's going to have a bunch of different things that don't make a lot of sense, meaning x's and y's and z's sometimes. Maybe for another video. Number 2, the area model is incredibly helpful when we talk about factoring these types of expressions. You see how easy that was? This video might be less than 5 minutes. Might be. Number 3, make sure that when we have these extra exponents, you factor things out very carefully. Like, for example, when we had the third power and the second power, well, they both have at least that second power in both of them. So make sure you factor them out the right way. See you next time.